All right, for the next example, we're going to solve for n. np2 is equal to 56. Well, np2 is equal to 56. So I'm going to try to algebraically manipulate the left-hand side. So np2 can be written as n factorial divided by n minus 2 factorial is equal to 56. Now, if I take this expression here and manipulate it, I could rewrite it as n times n minus 1 times n minus 2 factorial divided by n minus 2 factorial. And that's going to be equal to 56. I'm going to cross off common factors. And what we notice is n times n minus 1 is equal to 56. And right now, before you go out, now, this is brilliant. I mean, you know that n is a positive integer, right? N is the number of elements, and the number of elements is 0 or a positive integer. So can you, now take a look at this. Can you identify a number times, or an integer, times one less than that integer is equal to 56? What two consecutive numbers multiply to 56? Well, 8 and 7 is equal to 56. I mean, you can also factor that. So therefore, n is equal to 8. I mean, you can factor that, use the quadratic formula, whatever you want, but n is going to be equal to 8. Permutations. Now, we're going to introduce the notion of constraints. Often, with constraints, you have to deal with the constraint first. So, how many ways can we arrange the letters of the word Tuesday given the following conditions? No conditions. First, I notice that Tuesday is 7 letters long. 1, 2, 3, 4, 5, 6, 7. So if there are no conditions, it is going to be 7 factorial. And easy enough, you can take out your calculator and figure that out. So now, how about if t has to be in the middle? Well, we still have 7 letters. And what I'm saying is t has to be in the middle. So allow me to put t in the middle. There's only one choice for that. So if you want, I could write Tuesday, and I've just placed the t in the middle. Well, now there's 6 times 5 times 4 times 3 times 2 times 1. Well, there's 6 letters left over, then 5, then 4, then 3, then 2, then 1. So really, this is equal to 6 factorial. Now, the new arrangement has to start and end with a vowel. So if I take the word Tuesday, and this really does help me out writing this, it has to start and end with a vowel. So I'm just going to say, well, there's 7 letters, and I notice that 3 letters are Tuesday. So there are 3 choices for the first letter, and then 2 choices left over. Now I'm going to place the remaining 5 letters in the spaces, so that I would have 5 choices times 4 choices times 3 choices times 2 choices times 1 choice. In other words, I'm going to have 6 times 5 factorial, right? 3 times 2 times 5 factorial. Or, I mean, this can be expressed as 6 factorial, or very simply, you can just simply multiply these numbers. So 6 factorial is going to be 720 different ways I can write it. Whew, I'm getting tired here. I mean, let's continue on because we're having so much fun. So the new arrangement has to start with a T and end in a Y. So I'm just going to make my new arrangement. It still has to be 7 letters long. I could write Tuesday like that. So I have 7 spaces. I have one choice because it needs to start with a T, so that gives me exactly one choice. And I have one choice because it has to end in a Y. And now I notice that there's 5 letters left for this, then 4, then 3, then 2, then 1. In other words, this can be equal also to 5 factorial, or 120 ways. Ooh, the new arrangement cannot have a vowel at either end. So it cannot have a vowel at either end. So now I've made the assumption that Y is not a vowel here. So a vowel cannot be at either end. So I am going to put non-vowels at the end. So this is a non-vowel, this is a non-vowel, that's a non-vowel, that's a non-vowel. So at this end, there are 4 choices. I'm going to eliminate one of those. At the other end, that takes out another consonant. And then I'm going to place the other letters. So now there's 5 choices for the second letter, 4, then 3, then 2, then 1. So really, you could multiply this out. That's 5 factorial, is it not? So 4 times 3 is 12 times 5 factorial. And what we get here is we get 14